All right, I hope you don't mind Hamilton Hammy G6W. I thought I would go ahead and respond to this question in video format because honestly, it's a really good question and something that kind of bothers me when I read through this paper. But really, it's not a big deal. It's a personal preference when it comes to notation is really what this comes down to. And so let's just take a few moments to break down your question and explain. So why is it okay in this proof and subsequent videos to use the log density function and not the full likelihood function? Okay, so I understand the density can be used as a likelihood function in the case when you have just one observation. And that's basically what they're doing. They're basically saying they have one observation. But the full likelihood is based on the product of n different PDFs. So absolutely, you are correct. And they are basically acting like there's one observation. But turns out that all of their proofs and everything, if you just add a little sum sign, it's all the same. So it really doesn't matter. But to be rigorous and a little clearer with the notation, I agree that they probably should have included more than just one observation. So let me go to my Blackboard and just kind of, break out what I'm saying here. So, we have for a single z, the density function is this function of z, and then we have theta and phi equals e to the power of alpha of phi, z alpha g of theta, z of theta, z times theta minus g of theta plus h of z, close the parentheses for that alpha, and then we have some beta of phi and z. Okay, and that's for a single observation. So then if I have more than one observation, so say I have z1, z2, all the way through to zn, and they're independent, right, then their joint distribution, so the distribution of all of them, I'm going to use just one z here. Maybe I'll underline it to note that it is a vector of z's. So an n by 1 vector. I'm going to have theta, and theta is also going to be an n by 1 vector. And then I'm going to have phi, which is also a n by 1 vector. Okay? Because these theta and phi can also change for every z. All right? Just as long as the z's are independent, then this is going to be the product. So this is capital pi or large pi noting product. From k equals 1 to n of e to the alpha of k, subscript k, z theta k, zk times g of theta k, h of z k, close those parentheses, and then beta. So you see, I've just basically have added subscript k to everything, right? And you might be wondering, why am I using k and not I? Well, let's go back to the paper. Later, as I continue reading, down here in section 2.1, they do talk about a sample of n, right? And they're using the subscript k to go from k equals 1 to n. Okay, so eventually they do break this out to having more than one observation, and I think that all of these should have the subscript k. And the reason why they're not is mainly maybe because they didn't want to type it out, or remember, this was written in the 70s, so I'm not really sure how they typed it out or how they wrote it. Maybe, just things were different back then. Okay, but yeah, they use the subscript k later on for the sample of n. Okay, so then when I have my log Let me use underline. So then if I have my likelihood function, which I want that to be the log of my joint density functions, right? This is going to be the log of that product from k equals 1 to n of e to the power of all this stuff. I'm not going to write it again. Okay, just put that stuff down there. And then the log, basically that makes that a sum, right? The log of a product is just a sum. So from k equals 1 to n of this, the log of the exponent, the log of the exponent, then that cancels as well, and you're left with just the stuff that's on the inside. Okay. So basically, when I have more than one observation, it's the sum of the likelihoods for an individual observation. Right? So in our paper, if they're using individual likelihoods, then the joint likelihood then would just be the sum of those individual likelihoods. Okay. So all the results of the paper, oops, let me go back here to everything that you see here will still hold true, because, when I take the sum of, k or n individual likelihoods, it'll still equal 0. The sum here equals the sum there. Basically what they're doing is they're avoiding writing that subscript k every time and avoid writing that sum every time, but all the results hold true, okay? Regardless of, if you write it for a single observation or if you write it for n independent observations. It's just less notation, less things to write if you don't have to include that summation sign and that subscript every time, okay?